Hello everyone. Radhe Radhe and welcome back to my channel. Today we are discussing the today's LeetCode problem of the day. It is named smallest subtree with all the deepest nodes, and I found this problem to be very easy. Just the implementation was a little trickier if you are a beginner, but otherwise I think this is a very easy problem. Anyways, let's continue. We have been given the root of a binary tree. The depth of each node is the shortest distance to the root. So basically depth is defined as the smallest path which leads to the root node. So the depth of 5 is 1 because in one distance we reach 3, right? The depth of 2 is 2 essentially because in 2 distance we reach 3, right? And so on. So we need to return the smallest subtree such that it contains all the deepest nodes in the original tree. So we need to return a subtree such that it contains all the deepest nodes. Let's see what are deepest nodes. A node is called the deepest if it has the largest depth possible among any node in the entire tree. So deepest nodes are the nodes which have the largest depth, right? So in this case, the largest depth of nodes will be 3, right? Because 7 and 4 have depth of 3, right? In one length we go to 2, then we go to 5, and then we go to 3, right? So this has a length of 3. Similarly 4 also has a length of 3 or the depth of 3, right? So we need to return the subtree consisting of all the deepest nodes. So these two were deepest nodes, right? So we need to return the subtree. So we return this 2 or the address of this thing, right? We need to return the address of that node or that subtree essentially. So basically this problem boils down to, if I have a tree like this, just try to stick with me for 5 more minutes and you'll understand immediately what I'm trying to do here. If a tree is like this, right? So let's say if I have a tree like this. So the deepest nodes are just at the extreme bottom, right? So these two would be my deepest node, right? These ones, and I need to return a subtree consisting of all the deepest nodes. So this is the deepest node, this is the deepest node, right? So I need to return a subtree which consists of both of these nodes. So that is what? That is this node, because I need to return the smallest subtree, right? This because this would be a valid subtree also. This also contains these two nodes, right? But this has more nodes to it, right? And we need to, in this problem, we need to return the smallest subtree, right? So we'll just return their lowest common ancestor. That is what our goal would be, to just find the lowest common ancestor of all the deepest nodes, right? So I'll take one more example. If let's say if I have a binary tree like this, something like this, then what would be our deepest nodes? It would be this one, this one, this one, and this one. And now we need to return a subtree, the smallest subtree, which consists of all these 4 nodes, right? So we cannot return this or this, because then we will only cover these 2 nodes, right? Or these 2 nodes. In this case, in this particular example, we'll return this node because this is the lowest common ancestor of all the 4 nodes. This is the smallest subtree which consists of all the deepest nodes, right? So we'll return this particular node, and that's probably it. We can just find all the deepest nodes. We can keep track of how deep we are in the tree, and we can assign the depth of each node. We can essentially create a map. So let's say if my values were 1, 2, 3, 4, 5, 6, 7. So I'll assign the node 1 a depth of 0. I'll assign node 2 and node 3 a depth of 1. So node 2 a depth of 1 and node 3 a depth of 1. This is not the value, this is the address of this particular node, right? And now I'll assign node 4 the depth of 2, node 5 is depth of 2, 6 as depth of 2, and 7 is depth of 2 as well. And in this map we can find what is the maximum value. That would be our deepest nodes. So in this case the maximum value is 2, right? The maximum value is 2 in this particular map. So these 4 are our deepest nodes. So essentially we can add them to in our separate set. So these 4, 5, 6, 7, and note these are the addresses of these particular nodes. These are not the values itself, right? So I can add these deepest nodes into our set, and then we can find the lowest common ancestor of all the lowest common ancestor of all these nodes. And how do we find the lowest common ancestor is we can do something like this. We can create a function, separate function, and we can iterate on the entire tree. So let's say our tree, I'm iterating on this tree again, right? So I'm on this node. So I check, is this node in this particular set? So it is not. So I move on to the left and move on to right. So is this node in this particular set? So it is not. So again from here I go to here, left and right. So is this particular node in this set? So yeah, it is. So I'll return a 1. This will return a 1. Is 5 in this particular set? Yes, sure it is. So this will again return a 1. 6 is also in the set. This will return a 1. And 7 is also in this set. This will return a 1. So when we are standing at 2, we'll sum these values. So 1 plus 1 is 2. That means when we stand at 2, we have found 2 elements which are from this set, or which are deepest nodes, right? But we need 4 nodes for that node to be a valid lowest common ancestor, right? Because what this 2 means is we have found only 2 such nodes, or 2 deepest nodes, but we need 4, right? So we'll not do anything right now. Similarly in this case also we'll have 2 here, because we found 2 nodes, or 2 deepest nodes, and this 2 and 3 returns 2 to 1. This again returns 2, and then 2 plus 2 we add these values, and this returns 4, or this becomes 4 here, right? So as soon as this becomes 4, we see that the 4 is actually equals to the size of this particular set. So when this condition is satisfied, then I know I have found all the valid or all the deepest nodes, right? When the count of this particular of these elements, or the count of all the deepest nodes is equal to the size of the set, that means I have found all of the valid or all of the deepest nodes, and in that case I can set my answer to be the current node. Let's just call it root or node itself. So now my answer becomes node, and that's it. I just return this answer. So that's probably it for the problem. I'll show you guys the code. So this is the main function. I'm checking if my root is the only one or only node. So I'll just, in that case, I'll return my root. Otherwise I've created a map. I'll assign depth of each node, or depth to each node. Then I run this function find depth. I'm initializing the depth with 0, right? So depth of current node, I assign it with d, and if the left children exist, then I go to left and I increment the depth by 1, and if the right children exist, I go to right and I increment the depth by 1, right? So this essentially creates this this map of depth, and then I find what is the maximum depth in all of our nodes and the elements, and then I construct this set. The elements which have the depth equals to this maximum depth, I store them in a set, which we were doing here, right? As I said, this was not the value, but this was the address. So we're storing their addresses in the set, right? So we're doing that here, and we are finally calling this find function. This find is nothing but find LCA. This find is the lowest common ancestor of all our elements in the set, right? So this is essentially it. So I'm checking, I'm initializing a total variable. This means that how many deepest nodes have we found till now. If my current node is in the set, this essentially check if my current node is in the set. So if it is, that means I have found one deepest node, so I'll increment total by 1. If my root exists, if my left exists, then I'll go to my left subtree, and then whatever is the result of left subtree, I'll add that in total. Whatever is the result of right subtree, I'll add that to my total. And if my total equals to set dot size, that means I have found all the deepest nodes, and I'll set the answer to be root. I will initialize the answer here with null, right? If my answer is if my answer is also null, that means I haven't found any valid LCA, and my total found deepest nodes is equal to the set dot size. Then I initialize my answer with root, and I just return the total, right? And finally I just return my answer, and that's probably it. This code is a little messier, I think, because I wrote this not in the most cleanest way, but I hope you got it. This was fairly simple, straightforward problem, but in case you haven't got it, then please let me know in the comment section, and I'll see you guys in the next one. Thank you for watching, and Radhe Radhe.